All right, kia ora. Let's go through the answers for that CPR quiz that I've added for this week, which is your task number 2. Apologies, I don't have the exam printed out, so I can't annotate it, but it should hopefully make this video nice and short because most of this is stuff you can get off the marking schedule. I just wanted to kind of point out some key things as hints. So, this CPR quiz was all looking at the polarity of molecules. I just wanted to focus on that because I know you guys have done quite a few questions on shapes, but the shapes questions tend to tie into these polarity questions. This is from the 2021 question 3D, and what they've done is they've given you 2 different molecules, and basically they want you to highlight which one is polar, which one's nonpolar, compare and contrast the influences of that molecule, and explaining the why. So my first big hint to you for this is they're normally going to give you one polar and one nonpolar molecule, most likely, simply because they want you to be able to compare and contrast. However, I have seen every so often they give you 2 nonpolars or they give you 2 polars, so that's not a key guarantee, but most likely you're dealing with a polar and a nonpolar. The other thing is these things here with these guesses is basically a multiple choice question. So even if you don't know the answer, take a guess. I would say take a guess that one's polar, take a guess that one's nonpolar, and that's usually an achieve point question there. So don't leave that blank because sometimes that one achieve point can be enough to push you over to pass. So please do that. All right, then it wants you just to write a compare and contrast of that. So remember, when we are thinking about these polarity questions, you might have a quick mention on shape, but the main focus are asking if a polar bond's present. Is there a polar bond present? Are there any lone pairs of electrons? And how does the symmetry look? The other thing to keep in mind, especially if you're looking for that excellence level answer, is think about similarities and differences because you want to compare and contrast. It's in the instructions themselves. So when I look at these 2 molecules, I can see that both of them have a central atom with 4 chlorines attached to them. One's going to be polar and one's going to be nonpolar, and we need to explain the why that is possible. So do kind of keep that in the back of your head. Make sure you're using those linking words. So let's just have a look at the marking schedule so I can kind of quickly walk you through what's going on. And now I got to find the question. Which one was this? 3D. Cool. So first one is polar, second one is nonpolar, and I can quickly kind of look at that and explain it because I can see here that has the symmetry and that one doesn't with those lone pairs of electrons. So that was like I was saying before. Remember how even though all of these are going to be slightly negative and the lone pairs of electrons are negative, you would think, oh, it's negative all around, so it's symmetrical, so that all cancels. No, because those lone pairs of electrons have a different type or different amount of negativity, so that's going to actually make it polar. All right. Oopsie, that's not what I wanted to do. Have I opened the wrong molecule? There we go. So you see how in this answer you're using things like the word both. So this is that comparison that I'm talking about. Both of them are atoms attached to chlorine. And in each of the molecules, there's electron negativity difference. The PCl3, the dipoles are arranged asymmetrically into a trigonal pyramidal shape. So once again, you can integrate into some of that shape material to help you justify how you know it's not symmetrical. And there's a lone pair of electrons. The dipoles don't cancel. This is a polar molecule. In contrast, so you see that's again one of those linking words we're looking for to show that comparison. If you don't have those comparison words, you're not getting an excellence point, and I can show you right here. It says at the very beginning of that excellence point, compares and contrasts. If I don't see those words there, you're not getting the excellence point. So due to the symmetrical nature of the trigonal planar shape, the dipoles do cancel the molecules nonpolar. So they are recognizing that there are dipoles in this answer. Now, personally, I don't like this answer. I think it could be a bit more detailed, but I think they're being quite generous because this was the year of the pandemic and all the UAG grades and things like that. So what I would suggest you also would write is stating that between, each one of those atoms, the chlorine is the most electron negative, and so the chlorine will be slightly negative. So you can write in both cases, chlorine is more electron negative than phosphorus, than boron, and thus it's going to be slightly negative. So you can have that detail. I would. Remember, these marking schedules aren't the end all of perfection. And different marking schedules will have different difficulties levels. This one is an example of an easier one. Cool. Identify the polarity of both molecules. So like I said, that just circling and taking a guess could have gotten you an achieve point. Identifies the difference in electronegativity between atoms and bonds. So again, give me the definition of electronegativity. Boom, 2 achieve points right there. You've gotten an N2. Just from that, from real generic stuff. So do just give things a go, because you'll be surprised if you give things a go and you give it a go on all the exam paper and you leave nothing blank, there might be enough to scrape by to pass you. This one here, link symmetry or asymmetry, or cancellation, non-cancellation to one molecule. So you've just justified one molecule correctly. This also gives you some breathing room. Let's say you misclassified one of the molecules as being polar, and you wrote both of them up to be polar. Well, this means you can still get a merit even if you misclassified a molecule. So a lot of these things do have some generosity in the marking schedule. It does vary from year to year, but it's worth taking the guess. So let's say you're not sure which one's polar, but then write them both as polar examples and maybe you'll get an achieved or merit point for it. Always, always, always take a guess, and you can regurgitate general information such as, the molecule is not symmetrical. It will be polar. The molecule is symmetrical. It'll be nonpolar. You can just regurgitate generic stuff and you might be able to get some points there. So that would be my advice with this polarity question. There's a lot in here that you can just guess and maybe get some points at. All right, that's it.